First, we're going to do the problem 1 divided by 1/5. We need to think about it by thinking about how many 1/5 are in one whole. And we can do that by drawing a model to demonstrate one whole being divided up into 1/5. So we can see how many 1/5 are in the one whole. Once we start with our model, we're going to turn 1 into 5/5. So the denominators are the same in both 1/5 and 5/5. Now the problem is 5/5 divided by 1/5. So we're going to rename the model to show 5/5. So now we're going to go ahead and divide it into 5 equal sections. And now we are going to shade in all 5 to show 5/5. And now we can ask ourselves the question again, how many 1/5 are in that 5/5? So we need to circle the groups that are the size of the divisor 1/5. So we're going to circle 1, 2, 3, 4, 5. So there are 5 1/5 in 5. Therefore, our problem is 1 divided by 1/5 equals 5. Next, we're going to do another problem using models with 2 fractions. So it'll be 3/4 divided by 3/8. So that means we're going to do 3/4 divided by 3/8. In the first step, if we are using models, is to name 3/4 at 6/8 so that 6/8 and 3/8 have common denominators. And we do that by finding the LCM like we learned when we were adding and subtracting fractions. And we need to think, how many 3/8 are there in 6/8? So we're going to go ahead and draw a picture of that. So we have our box divided into 8 equal sections, and we are going to color in the 6/8 first because that's our dividend. So that is what we need to start with. So we'll color in 6/8. And now we need to think about how many 3/8 are there in those 6/8. And we're going to go ahead and circle those. I have a set of 3/8 here, and I have a set of 3/8 down here. So that means when I do 6/8 divided by 3/8, I get 2, because there are 2 groups of 3/8 in 6/8. In the previous slide, we learned that doing 3/4 divided by 3/8 equaled 2 because we renamed the fraction 3/4 into 6/8 and use a model to show how many 3/8 were in 6/8, and we got 2. Next, we're going to be learning how to do these problems without using models and instead using what we call reciprocals. And reciprocals are going to be so important as we use them throughout the rest of this fractions unit that we're going to learn more about what they are before we go on and start solving problems using reciprocals. Now, I just said that reciprocals are any two numbers with a product of 1. And I'm going to give you an example of that very quickly before we move on. Let's say I have the problem 3 divided into halves. Now, if I had the number 3 and divided it up into halves, I would have 6 halves in 3. Now, I would also, if I did 3 times 2, which is the basic multiplication fact, I would get 6. So if I had 3 divided up into halves, I would have 6 halves in 6. But also, if I did 3 times 2, I would get 6, which is the same as up above. That means that 1/2 is the reciprocal of 2. So we have 1/2 is the reciprocal of 2. Now, other numbers that are reciprocals, we could have 1/4. That would be the reciprocal of, we'll just write reciprocal of 4. And another example, 1/6, we could say is the reciprocal of 6. And that, knowing what reciprocals are, is really going to help us out when we start dividing fractions without using models and instead use reciprocals. So the main idea with dividing fractions is to multiply the fraction by its reciprocal. So when we had done the 3 divided by 1/2, we got 6. But that's the same thing as doing 3 times 2. We multiplied the 3 by its reciprocal. So we can apply that principle of dividing fractions by multiplying its reciprocal to that one problem that we had already done using the model. Remember, we had done 3/4 divided by 3/8. And we drew the model, we made our denominators the same, but we're not always going to have to do that. We could instead look at the divisor and take the reciprocal of the divisor. So we're going to keep 3/4 the same, and if you remember me saying when we divide fractions, instead we can multiply, which is going to be really important because we're going to switch that around. We're going to multiply by the reciprocal of our original divisor, which is 3/8. So the reciprocal of 3/8, how we find that is we just flip it upside down. So that means the numerator would become the denominator, and the denominator will become the numerator. So now the reciprocal of 3/8 is just 8/3. And we can go ahead now, because it looks like we have a fraction that we already know how to do with multiplication. And we can multiply 3 times 8, and we get 24. And then we can do 4 times 3, and we get 12. And we have an improper fraction right here because 24 is larger than 12. So that means we're going to need to divide like we have been doing with our multiplying fractions problems. And we'll need to do 24 divided by 12, and we know the answer is just 2 because 2 times 12 is 24. And we don't have a remainder, so that just means that 2 is our whole number. So the answer to 3/4 divided by 3/8 is 2, because we multiplied by our reciprocal to find that out. And this works out really well because when we had initially done this problem with the model, we found out there were 2 groups of 3/8 and 3/4. So this is a way to do it without the model by using skills that we already know and adding a reciprocal into the mix by multiplying it. Now we're going to try another example. We're going to do 1/8 divided by and 3/4. Now, if you remember from the last example, instead of using models, we found out that we can eliminate the use of models by instead multiplying by the reciprocal of the divisor. And our divisor is 3/4, so that's the number that we're going to have to find the reciprocal of. So the 1/8 stays the same, and instead of dividing, we're going to multiply by the reciprocal, and the reciprocal, we switch the numerator into the denominator's place and vice versa, so that 3/4 now becomes 4/3. And all this initial problem means is how many 3/4 are there in 1/8. So if we divided 1/8 into 3/4, I want to know how many pieces there are. And now in this problem that we have down here, it is a problem that we've already done before. or already have learned how to do, which is just multiplying fractions. So we can go ahead with our multiplying fractions skill and do 1 times 4, and we get 4. Then we get 8 times 3, and we get 24. And now we will need to simplify that fraction, and the greatest common factor of 4 and 24 is 4, so I can divide both the numerator and the denominator by 4, and I would get 1/6.